Good morning, gentlemen. Sorry I'm not going to be with you today. We have a COVID close contact, so I'm going to record this lesson and you can follow along, to take notes, do these problems with me, and then you have a homework assignment that's already posted on Blackboard. You're going to do that, complete that assignment as usual, and we have a quiz on this review material that's already scheduled in Blackboard. So we're going to stay on schedule with all of that. All right, so we're going to go over the substitution method. For the substitution method, you're going to replace any instance of a variable with the equivalent expression. You're going to plug that expression back into the other equation and then solve. You'll get a value for a variable, plug that number back in, solve, you'll get the value for the other variable. This method's best when at least one of your variables is already isolated. So let's see this in practice. So this first system, y equals 2x minus 5 and y equals 8x minus 11. I have y isolated in both equations. This is the easiest situation. So I'm going to take this 2x minus 5 and I'm going to substitute it in for y in the other equation. So I get 2x minus 5 equals 8x minus 11. Now I have one equation, one variable, kind of like one language. I can solve that. So now I know that x equals 1. And you can go back and slow that down, pause it if you need to. I'm going to plug 1 in for either of my original two equations. I'll just choose the first one. So y equals, instead of 2x, it's 2 times 1 minus 5. Y is negative 3. So my solution is x equals 1, y equals negative 3, or you could express it as an ordered pair, 1 comma negative 3. Either of those are acceptable. Now this second example, only one of the equations has a variable isolated. Doesn't matter which variable it is, I happen to have the y isolated, so it looks like it's in it is in slope-intercept form. It's the same method. Take that expression and replace all instances of y with the expression. Substitute it in. So now I have 4x, not minus 2y, but minus 2 times the quantity. I always use parentheses in this case, so that I remember to distribute. Now I have, it's a little more complicated equation, but I have one equation with one variable. It's multi-step. So I'll distribute, combine like terms, and solve. So now I've solved, I've got one value for x. I'll plug that back into one of the originals. Obviously, the equation where y is already isolated is the easier option. So instead of 3x, it's 3 times 2 plus 1. So x is 2, y is 7, or if you like, ordered pair, 2 comma 7. So that's substitution method. The elimination method, which if you remember right before exams, this is the method people liked better. We've got our equations in standard form. We want to multiply one or both equations if you have to make coefficients of the same variable opposite. Then we'll add the equations. One of the variables will be eliminated. We'll solve that equation, back substitute, and solve. So let's see this in action. Now, it would be great if I already had opposite coefficients, but I don't. So this first system, I've got 2x plus 3y equals negative 16, 5x minus 6y equals 14. I'm looking at 3 and 6. I can see 6 is a multiple. So the opposite of negative 6 would be a positive 6. I'll multiply my top equation by 2. So I get 4x plus 6y equals negative 32. You have to remember to multiply the entire thing. Second equation I don't need to change. Now I can add these two. The y's cancel out. I'm left with 9x equals, I think that'll be negative 18. So x is negative 2. Great. Back substitute that into one of the originals. I'll just choose the first. Use parentheses anytime you plug anything in. And solve. So y equals negative 4. So my solution, negative 2, negative 4. All right. Maybe you get a system where coefficients aren't multiples, so we have to multiply both equations. So I'm looking at the x's. To me, I think that's a little bit easier. I see 3 and 4. 12 is a multiple of both of those, so I want to make one coefficient positive 12, the other negative 12. So I will multiply the top by a positive 4, the bottom by a negative 3. And I get 12x minus 28y equals, I guess that's 216. For the bottom, I get negative 12x, negative 15y, positive 42. Really have to be careful to distribute. That's, people understand the method, but that's just a little arithmetic mistake that guys make. All right, the x's are eliminated. I get negative 43y equals positive 258. So now divide both sides by negative 43. And I get y equals, I think that's negative 6. Right? You're allowed to use a calculator at this point. Now you'll plug the negative 6 in for y in one of the original two equations. I'll choose the bottom. So 4x plus 5 times quantity negative 6 equals negative 14. 4x minus 30 equals negative 14. 4x equals 16, x is 4. So our solution, 4 comma negative 6. So those are two methods. Actually, we had a third method, if you remember, it was the graphing method, but we're never going to use that. If we already had a graph provided for us, like you did on the midterm exam, then you would just find the intersection. But typically, it's way easier to solve using one of these two algebraic methods. So now the next thing we want to look at, final thing, are special cases. So sometimes we're going to just jump into the problem. We'll go about substitution or elimination, and something weird is going to happen. Our variables are going to disappear. So one of two things will be true. Either the variables disappear and what remains is a true statement, something like 0 equals 0 or 8 equals 8. In which case we had coinciding lines. Our equations were actually the exact same equation, just in a different form. And we have infinitely many solutions. Not all real numbers, but infinitely many solutions. The other thing that could happen is the remaining equation is false, something like 0 equals 2, in which case we had parallel lines and there's no solution. So let's look at these in practice. Okay, so this first system, I have a variable isolated, so I'm going to jump right into substitution. I'm going to plug my 2x plus 3 in for y. So I have 4x minus 2 times the quantity, 2x plus 3 equals 7. I will distribute. Oh, and look, 4x minus 4x is 0. So I'm left with negative 6 equals 7. That's false. So there is no solution. I mean, if I really paid attention at the beginning, I guess I could have seen that these were the same equation. They have the same slope. I'm sorry, not the same equation, that they are parallel lines, same slope, different intercepts. But I think even looking for that takes more time than just jumping into solving. So if your variables drop out, double check that your arithmetic is correct. If you're confident that your arithmetic is correct, then you know you have a special case, no solution, or all real numbers. My second example, right, both my equations are in standard form. Now, as you get a little more experience, you'll see, hey, something's weird. It just looks like the second equation is a multiple of the first. Let's see what happens. I multiply the top by negative 2. I get negative 6x minus 10y equals negative 18. Second equation, 6x plus 10y equals positive 18. The x's are eliminated. So are the y's. So is the constant. I get 0 equals 0, which is true. 0 does, in fact, equal 0. So this would be infinitely many solutions. So those are our special cases. What I want you to do is, I hope you have these problems worked out in your notes now. I've shared a Google Doc with the written out notes. So you have a homework assignment where you're going to solve a couple problems using the substitution method, a few using the elimination method, and then a few problems using whatever method, 6 problems using whatever method you choose. Do these in your notebook, normal homework submission procedures. So just label this system of equations review homework and submit that online. Not sure when I'm going to be back next. Hopefully I'm in school on Wednesday rather. But if not, I'm going to just continue to do these videos so you can stay on track. If you have any questions, send me an email. Even during a class, I'll have my computer open and I'll be able to respond pretty quickly to help you with this. If you want to send me questions during community period or right after school, you can do the same thing, and maybe we can try to jump on a Zoom if need be to get you straight. All right, guys, have a good day, and I hope to see you soon.